So we have this problem where a ball player catches a ball 3.88 seconds after throwing it vertically upward. So we'll have some initial velocity here. The ball's going to rise and reach a maximum height where its velocity is going to be 0. And then it's going to fall back down and they're going to catch it. So the total time is 3.88 seconds. But we can see we have two paths here. So it's going to be easier to think of this in two parts. And so the time it takes to get to the top is this total divided by 2. Because these are symmetric, and all our equations have the symmetry, the time to get to the top is half the total time of flight. So what we can do is, for what speed did he throw it with, we can look at the final velocity is the initial velocity plus AT to the top. So in our case, the final velocity when it gets to the top, everything on the top of a free fall is 0. So initial velocity is what we're looking for. And our A is our lovely 9.8 meters per second squared. And our T over T is this 3.88 seconds, but divided by 2 again, right? Divided by 2 because we're looking for half of the journey. So I want to take all of this negative quantity and I'm going to move it to the other side of the equal sign. So I'm going to add it to both sides. So I get VI equals 9.8 meters per second squared times 3.88 seconds divided by 2. And plugging that into my calculator, I get 19.0 meters per second. Alright. Well, now to find what height it reached, we're going to take the same half of a path, but we're going to use VF squared equals VI squared plus 2AY. I'm going to solve for y. This again is 0 at the top of a flight. I'm going to have VI squared equals negative 2AY. Solving for y, I'm going to divide 2a by both sides. Y equals VI squared over 2a. Well, a is negative 2a. Keep my negative sign. But that's negative 9.8. So we're going to look at 19.0 meters per second squared divided by negative 2 times 9.8 meters per second squared. So let's do this here. 19 squared divided by 2 times 9.8. Oh, and let me remember, this also has a negative sign, so we're going to get a positive number out. And we're going to get 18.4 meters. 18.4 meters. So by breaking our time in half and recognizing at the top is the halfway point, we can simplify this a little bit. And it's a good thing sometimes to break down our motions into segments, especially around points where things turn, because we know what's happening with velocities a lot of times at particular turning points.